Now, Matt, you specialize in translating complex climate data into actionable strategies. Could you walk us through an example of how you've helped a client move from risk identification to resilient design solution?
When I was thinking through this, one case study came up, and it's a project that we just completed for the Arizona Department of Transportation, specifically on their State Route 88, which is essentially a rural access road that helps recreation enthusiasts and outdoor enthusiasts access different national forests and wilderness areas outside the Phoenix area of Arizona. And what we did was...
What if you could predict design failures before the first shovel even hits the ground? In this episode, I'm joined by Matt Huddleston, PE, Principal Consultant of Climate Resilient Strategies at Resilient Analytics, to discuss how engineers can move from reacting to climate risks to designing for long-term resilience. We'll talk about how civil engineers can use climate model projections to future-proof their designs, how evolving standards like LEED and ASCE are codifying climate resilience, and how municipalities and corporations alike can turn complex data into actionable strategies. Whether you're already building for a changing climate or just starting your journey, this conversation will give you practical insights to create infrastructure that lasts. Before we jump in, I wanted to tell you about our AEC PM Connect event, an interactive experience where civil engineers can sharpen their project management skills through real-world sessions on topics like earned value, AI in project management, and risk management. Visit aecpmconnect.com and register today. We currently have events in Kansas City and New Jersey, with more coming. I'm your host, James Taylor, and this is the Civil Engineering Podcast, the industry's leading show for civil engineering professionals, ranked as the #1 civil engineering podcast by FeedSpot. It's now time for our Civil Engineering Conversation of the Week with Matt Huddleston, PE, Principal Consultant of Climate Resilient Strategy and Resilient Analytics. Matt, welcome to the Civil Engineering Podcast.
Hey, James, thanks so much.
All right, let's get into it, Matt. Can you share a little bit about your background and the path that led you to your current role as a Principal Consultant at Resilient Analytics?
Yes, certainly. So I'm going to start at the beginning. I went to school for civil and environmental engineering and minored in mechanical engineering because I couldn't decide exactly where I wanted to focus, but I knew engineering would, provide that variable path or the capability to follow one at least. So after graduation, I practiced as a mechanical design engineer. I guess technically would be called an architectural engineer because I focused mostly on building system design, sustainability master planning, energy modeling, and things like that. And so worked in that space and, the design and construction world. And then about 6 years ago, jumped over to the resiliency space, which was fitting because I feel like it's really a consolidation of a lot of different disciplines. And so since then, at Resilient Analytics, we're a small group, so we wear a lot of hats. I do everything from project management, technical development, business development, and really everything in between. And so I've been combining my multidisciplinary knowledge for the last 6 years here.
What led you to make that switch?
Yeah, so I was interested in, my previous roles. I was really interested in that sustainability consulting role and, on master planning projects. It really is what drew me in and where my interests really lied. And so initially my thought was I'll go into a more sustainability consulting focused role. And for those familiar with resiliency, and we can define that, but how I normally think about it is that resiliency is assessing how the environment affects us or affects our assets, whereas sustainability is really just the flip of that, where we look at how our assets or ourselves affect the environment. And so what I did end up in is essentially, I think in a lot of ways part of the sustainability consulting world, but more focused on kind of the flip side of it. And so I think it was really just a case of following my interests is what led me here.
I love it. Hey, you gotta follow your passion so you stay in things.
Right.
Now, Matt, you specialize in translating complex climate data into actionable strategies. Could you walk us through an example of how you've helped a client move from risk identification to resilient design solution?
Yeah, so when I was thinking through this, one case study came up, and it's a project that we just completed for the Arizona Department of Transportation, specifically on their State Route 88, which is essentially a rural access road that helps recreation enthusiasts and outdoor enthusiasts access different national forests and wilderness areas outside the Phoenix area of Arizona. And what we did was we worked with our parent company, Stanley Consultants. So we are owned by them, and they won this job with ADOT, and they needed to assess. It was essentially a design concept study that they needed to assess different design strategies that could help ADOT to figure out the best concept for this SR88 to pursue in order to alleviate what was really continued closures due to wildfire and flooding impacts that road was
Interesting.
experiencing. And so what we did was come in and help Stanley look at, as part of the report, look at future conditions for wildfire and for different runoff that they might experience in the design lifespan. So they decided on 2050 as the lifespan that they wanted to look out to. And so what we helped Stanley do was assess, well, this is what runoff looks like both in 2030 and in 2050. And this is what that could look like within your design concepts, the various concepts that were presented to ADOT. And so in the end, ultimately, we helped them to narrow in on a number of different options that ADOT could consider. So one being design for today's storm, essentially the runoff that they see today. One being designed for the 2030 storm, in which case the 2030 storm was increasing about 50%, and then or designed for the 2050 storm, which was the ultimate, the most, I guess, resilient option, and that resulted in about an 80% increase from today's
Wow.
runoff rates. And so we helped them. That really ultimately led to the formulation of these design concepts and different options that ADOT could pick.
When you're talking about the storm events, you're talking about stormwater and conveyance and design and all that stuff. Was there any other aspects to that study that was looked at besides stormwater and how to keep that in check?
Yeah. So the ultimate driver for this study was actually a wildfire that impacted the area that SR88 ran through. And the wildfire, we also have seen this in other locations, essentially burned the trees and the shrubs in the area and made it more susceptible to landslides and things like that during
Phew.
extreme precipitation events, because the trees and the shrubbery were no longer holding the ground in place, essentially. And so they also wanted to assess the risk of continued wildfire exposure or worsening wildfire exposure. And so we did assess that as well. And, it didn't result in necessarily a design concept alternative because it was outside the scope of that route, but it did help to assess, whether they needed to anticipate further disruptions or further impacts from wildfire. And so that was the other aspect of the study.
Yeah, I know the runoff aspect after a wildfire was a big topic with the California wildfires that took place. And hey, it's a common no matter where you're located at is if you no longer have that vegetation, you no longer have those things that are slowing down the runoff, which causes flooding, landslides, other things
Hmm.
from occurring. So
Right.
very interesting study. It sounded like.
Yeah, it was definitely an interesting one. And I think a really good example of how resiliency can be included in a project without having to go, add a ton of budget or go add a lot of time to the schedule. It really just was incorporated into it as another consideration. Budget was one, resiliency was one, and access for recreation. Those are three examples of, criteria that would help to select a design alternative. There were more, but, layering resilience in as one of the considerations, I think, was a really smart move by ADOT. And I think a way that one takeaway is that that's a way that it can be incorporated by others in the future.
I was gonna say, the term sustainability and resiliency and those types of things. I think sometimes they get a little bit of a negative connotation because about the amount of cost it can associate with it. But realistically, if it's part of who you are and what you're doing, those resilient items, you're looking at the long term success of, in this case, infrastructure of roads, those types of things. Those are the things that really, as engineers, we can utilize to help our clients continue to meet their needs, even though there might be a slight increase. It's not always about the budget.
Right, exactly. And I think even if budget is the main driver, there's categories, or I guess degrees of resilience. You
Yeah,
can have the most resilient project ever that would cost the most, but you can also do 50% or 20% of that and you're still more resilient. And it's all coming down to, how critical is my asset that I'm talking about, or how
yeah,
critical of a service does it provide? And it helps you to narrow in on exactly what condition you want to plan for. And so I think that's another thing. It's not binary. You can pick the most appropriate solution. And, that's not so different than a lot of different considerations that go into, value engineering and deciding on
right.
a project's design.
Matt, when it comes to using climate model projection data in civil engineering, what sources should engineers rely on and what should they watch out for in terms of data quality and relevance?
Yeah, there's a lot of data out there. And perhaps not surprisingly, when you look at climate projection data, if you put that into Google, a lot comes up. And I think it's probably easiest to start at the top. So, at a global level, there's things called global climate models, and those are released every so often by the Intergovernmental Panel on Climate Change. And essentially, these are models, a variety of them. You can think of it as a model library produced by groups, research institutions, academic institutions globally, and they all simulate future conditions for different things like temperature and precipitation and those
Right,
conditions that we're concerned about as engineers. But those global models, as they sound, cover the entire globe and are very granular, or very coarse. So they're not quite granular enough for us to apply, for example, for
right,
SR88 or for a city or for a stormwater system. You want something more granular than that. And so when we start to think about what options are available for that sort of data, there are some options in the US, like Atlas 15, the upcoming release, will have some good IPCC based data that you can use for stormwater calculations, or, let the national climate assessments have some data. Universities like the University of Minnesota has a climate viewer that has some really good granular information. EPRI has some energy focused resiliency data. A lot of times these things are pre-packaged in viewers that make them really great, granular, defensible, peer-reviewed data. The only issues that we've run into are that it's pre-calculated. So, if you need average summertime temperature, it works great. But in the case of like a project that you might need the 500-year return runoff value, it might be hard to find that in some places. Like you might get lucky and you might have a viewer that has that exact metric, but sometimes you need the ability to customize your own variables. And so the IPCC data that drives a lot of those sources that I just discussed is also available publicly. It's a large data set, but it is available. And if you are able to use that data and you can manipulate it yourself, you can really get customized data that will fit any situation. There are definitely limitations to look out for. Like, this data is not great at predicting extremes like the polar freeze that happened in Houston a number of years ago, or tornadoes. It's not good for things. We definitely draw the line a lot of times defining forecasting versus projections. And we're not saying, it's not like a climate forecast where, 10 days from now, we know vaguely what the temperature will be. We're not
I was
doing
say
that for.
those are never right anyway. Let's be real,
Right,
right? I mean,
exactly. Yeah, we like 10 days is hard, let alone 30 years. So what
yeah,
we it's a lot of education around, these are long-term trends that these projections are helping us understand. And there's just inherent uncertainty. So, there's different ways to deal with that uncertainty. Like some models, for example, around heat, they agree very well, while around precipitation, there's a lot of divergence and uncertainty. And the important way to deal with that is use as many models as you can, because they help you understand that full range of potential outcomes. And so it's called a model suite that will help you avoid those uncertainties. You can pick different emission scenarios to help avoid emissions uncertainties. And so, as it might sound as I'm communicating these things, there's a lot of data to consider, but it's best to have, a climate scientist expert in the room helping you decide, which solutions or which conditions should I be planning for, and
Yeah.
what things do I need to consider that really allow me to align with how this data can be used, and probably more importantly, how it can't be used. And so there's definitely some guidelines there that are best practices to follow.
Are there any, I guess, changes to how climate resiliency is being codified in today's standards? Something like, I guess, LEED or through ASCE guidelines? And just how can engineers ensure their projects align with these evolving expectations?
Yeah, it's definitely a quickly changing landscape in that regard. Like you mentioned, LEED version 5 for the first time has climate resilience codified within it. It's actually a prerequisite now to do a vulnerability assessment for your project. So, in order to be LEED certified under LEED version 5, you have to do a vulnerability assessment to determine how climate today and in the future will impact your project, and then list some options that you've considered for basically what we call adapting to those vulnerabilities and making your project more resilient. So yeah, LEED is a great example. There's ASCE. It's actually ASC 7-22. Recently, well, in 2023, they changed their guidelines to basically say rather than including the 100-year threshold in your design, you should consider the 500-year flood as your guiding threshold to help basically protect buildings and other structures from future flooding impacts that are in many cases worsening. There's different guidance that has been enacted, different policies in the National Park Service, the DoD, some municipalities, and I think more and more in the future, that require resilience to be considered in master plans and designs. And so, I've heard ASHRAE including some things in their design guidelines. And I think there's going to be more and more of this standardization and design guidance around this, but those are some examples that we've encountered and seen enacted to date.
So, Matt, how do you approach resilience planning differently when working with global corporations versus municipalities or government agencies?
Yeah, that's a good question. There's a lot of differences. I think probably primarily is their drivers. In a lot of cases, regulatory drivers. So, from the perspective of global corporations, the way I think about it normally when they're doing this sort of work is looking at their climate related financial risk from their investors' perspective. And for example, in the EU, in the UK, and actually also in California, there are regulatory requirements that companies over a certain size look at their climate related financial risks. So that could look like, a manufacturer that has a global supply chain and depends on an agricultural product from one part of the world. They might look at climate projections at that critical node in their supply chain to figure out the risk of those projections negatively impacting their ability to continue operating as expected. And so what that is really doing is helping their investors be well educated on what they're investing in for the long term. From the public perspective, there are also regulatory drivers. I'm most familiar with those in the US, where DOTs have opportunities with protect funding to do resilience improvement plans and get funding for those resilience improvements that they identify as most critical, which also applies to MPOs as well. And in some cases is no regulatory driver, and in those cases, I think the it a lot of times actually is pretty similar. You're trying to identify risks. Really, it's a lot. The similarities start to appear there, where you're really trying to identify vulnerabilities to future climate conditions and help either the company or the public entity, whether that's a DOT or the municipality, to adapt to those vulnerabilities. And it's data driven. Ideally, you identify risks and then you identify solutions. And so I think those are some similarities that they actually have. And then they both typically will have a portfolio of assets. I think this highlights some differences again, where when you're dealing with a municipality, their asset classes or types are pretty consistent. Like you would expect a municipality to own different, maintenance buildings, city hall, maybe roads in some cases, or that might be allocated to DOTs. Where if you're dealing with private companies, depending on the company type, it could be anything that you're dealing with. And so
Sure.
the vulnerability assessments and risk assessments look a bit different for private companies, whereas with municipalities and DOTs, a lot of times it's a pretty standard set of vulnerability assessments that are done.
I would think that there's a little bit of a difference in how you approach things when it comes to, like, you mentioned the differences of regulatory versus kind of a need. You know, do you find that it's easier doing one or the other of like, hey, regulatory, we have to meet these requirements and that's it, versus need, we don't know what the need might be. We kind of have to dig into it. Like, is there a difference between the two, or is it kind of similar no matter which way you look at it?
Yeah, I think there's certainly a difference when it's need based and the client ideally sees the value in perhaps some upfront investment in studying and considering what would make them more resilient or make their assets more resilient. I think they're more open to education and to really identifying the best value for them. And I think that opens up a more comprehensive look at this sort of a thing. There's a lot that can be done that goes beyond the regulatory requirements. And so, if it's simply done for regulatory reasons and they just want to meet the base requirements, I think it leaves a lot on the table as far as potential around future resilience, or really what that comes down to is the value for them. And I think more can be done than the regulations require in a lot of cases. And so I think, yeah, it comes back to, I think, really the educational component and educating clients and public entities and companies about the value that they can grasp from essentially investing some now to avoid either more downtime or additional maintenance costs or the negative impacts that would happen if they didn't consider these future conditions at all and let them come and
Yeah.
react as they happen rather than proactively assess the best methods to deal with those before they happen.
Yeah, I was gonna say, I would think just like anything, solving someone's problems based upon a need that they have has to be so much more rewarding, and you get a better client experience with them versus someone who says, "I'm being told I have to do this. Can you just get it done for me?"
Right.
It seems like your problems are different in that regard, and um, yeah, I would think that just like anything, you're gonna have a better client experience when you're solving that problem.
Right. Exactly.
Matt, based on your experience both as a design engineer and a sustainability consultant or resiliency consultant, whichever way you want to put it, how can civil engineers and municipalities practically begin to integrate sustainability and climate resilience into infrastructure planning?
Yeah, I think one thing that comes to mind first is an interaction I had with a fellow engineer recently on a project that we were looking at transportation assets. And the point was that just like in transportation, how all projects are safety projects, like you would never leave
Yeah,
the safety consideration out of a transportation master plan or design
right.
because that wouldn't meet the engineering standard of care. You, I don't think, should leave resilience out of not just transportation projects, but really any engineering or master plan project, because we're designing traditionally to historic conditions, but we've seen already that those in a lot of cases don't hold true and will hold less true as we continue to go forward. And you think we've seen a lot of impacts recently, like maybe in the last 10 years, but a lot of these things that we're designing are intended to last 50 or 100 years. And so the conditions that they're going to be dealing with look a lot different. And to settle on today's conditions, I think,
Right.
is short sighted in a lot of ways. And so I think to begin to account for that or to begin to look at that, it looks different. So, from the perspective of DOTs or local governments or other agencies that want to incorporate it into their portfolios and operations, I think first thing is to help with your staff to understand resilience is to define it and to understand what you mean and what your goals are around resilience. And so define resilience, update your frameworks and your master plans and your long range transportation plans, asset management plans, all those things that you might have to incorporate at least the consideration of resilience, not necessarily that you have to follow through with everything, but at least understand what the vulnerabilities might be. And then, embedding and streamlining it into the project process. Cause I think a lot of cases people are short on time and it seems like a big task, but it's really not. And it can be very simple. And so I think just helping answer those questions and alleviate those concerns early and easily in the beginning of a project process can make it more stomachable to incorporate. And so I think really just that boils down to helping your constituents and your employees be more familiar with resilience. And I think from the engineer's perspective, if you're a consulting engineer, it's educating yourself so that you can educate your client. And so, that can look like educating yourself on tools that are available, whether it's the data sets I talked about, or, the tools that you can use like EPRI's Climate Ready tool or the US Climate Resilience Toolkit, just to name a few. Educate yourself on the guidance that exists in your discipline's agencies like federal highway or state DOTs or ASCE. A lot of them are starting to have at least some form of resilience in their guidance, if not very established forms of resilience. Become familiar with, adaptation strategies that can be options for to basically alleviate risks from future, whether it's flood, wildfire, any of those hazards. And then funding, I think, is a big one on both perspectives, where if you can be more familiar with funding opportunities that are available, I think it'll make it a more attractive discussion when you start to have capital improvement discussions and things like that. And so there is a lot of funding out there available. And so just becoming familiar with what that looks like in your discipline, I think, is a great first step.
I want to go back to something that you said, which is about schedule. And I think it's a great point because, man, I mean, there's all the studies out there of, we're way behind on getting infrastructure projects completed. There's not enough engineers to complete the projects. Oh, by the way, now we want to introduce this other aspect of not just thinking about how do I solve it for now, but how do I look 50, 100 years down the road. And you kind of mentioned that, setting it up front, it doesn't take a lot of time. If you have to go back and do it later, that's what kind of causes that schedule issues. Can you talk a little bit about that aspect of it?
Yeah. So I think uh, when people think of the term resilience, it's probably a pretty nebulous term that
Yeah.
it could look a million different ways, especially when you start thinking about all the disciplines that are out there and all the perspectives that can be taken. Like, are you a design engineer working for a client? Are you on the client side and looking at a whole host of projects, or are you focused on one project? So I think to take that idea of the nebulousness of it out of it, I think codifying it within an agency, say you're a DOT, like making it a standard process really takes the questions out of it, because I think those questions and the
Yeah.
unlimited forks in the road of like, do I do this or this? What do I aim for? I think taking those questions out of it really help to streamline the process and take the unknown. You can answer a lot of the questions up front, and then the ones that you can't, make some, maybe it's a decision tree or like a decision matrix. Like, is your asset already vulnerable? Does it already see impacts? Here, use this tool. Does it have impacts in 2050 or in the design lifespan that you're planning for? And really, like I said earlier, there's degrees of resilience. It's not that we have to make every project bulletproof against any hazard it will ever face. If it's a nuclear plant or something very critical, we probably want to lean more on the conservative side. But maybe we accept some level of risk for other assets. And so making those decisions as early as possible, or ideally codifying them and making it a process that's already established before a project starts, I think
Yeah.
raises that level of efficiency to a point that, we can highlight that this doesn't have to be a huge additional task. It can be very simple. And, in some cases, if you do have to dig in a bit more, have resources that point to how to do that. But in a lot of cases, you won't have to, and it'll benefit everyone in the long run.
What key steps or considerations should engineers follow in translating climate data into actionable design decisions that enhance resilience?
Yeah. So I think, that codified set of responses that I started to touch on is in a lot of ways how I
Yeah.
would think about it. When I think at a high level how something like this goes normally, how you would do a resilience assessment on, say, a bridge design or any really incorporating the resiliency assessments into engineering designs. I think of four steps. So, first being data compilation. So, climate projection data, asset data. So, if it's a bridge, like how old is it? What condition is it in? Is it scour critical? When has it been updated? Things like that. What's its low span elevation? So, understanding set the scene almost so that you have all the pieces to plug into the functions and the equations in the future or as you go on. So data compilation and then model development. So figuring out the vulnerability model. So is my bridge sensitive to a flow increase of a factor of 1.5? What's the sensitivity that exists there? Because it might not be, you might find that the bridge isn't vulnerable at all. And that vulnerability assessment model is what you need to figure out. Like, where's that line lie? And then doing the analysis. So calculating the risk of that bridge having negative impacts from scour, overtopping, or whatever it might be. And then looking at the results. So I think an important thing we run into is, I mean, I touched on how big some of these models are and how much data is out there. It's really important to consider all of that data and use it, because having a robust analysis will make the results more dependable. But another important thing is boiling those results down to an understandable point, either for the engineers you're working with or for the client to understand. And so I think that's a big item to aim for. And so, along the way, those are the four steps I think of. And some important questions to ask before you get started or as you're getting started is like, what's the intended lifespan that I'm aiming for? That'll help you inform where in the future you want to look, as far as like, do I look at 2050? Do I look at end of century? And, this is oftentimes a client discussion as well. Selecting which scenario, which greenhouse gas emissions scenario do you plan for? Basically, like how warm will it get in the future? How many greenhouse gas emissions policies will be put in place or won't be put in place in the future? So that helps to steer where you plan and really helps to alleviate the uncertainty. Where you're located, because if you're in the continental US versus on an island or especially international, the data sets look different. And if you're coastal
Much different.
versus,
Yeah.
yeah, they change a lot and vary a lot. And so there's different models that fit better in different locations. If you're including things like sea level rise models, that's just a different consideration. And so where are you located is one. Which asset types are you expecting to deal with, and what's their vulnerability to the environmental conditions that they operate in? Answering those questions ahead of time will help you really make this process more efficient. And then what goals do the client have? Do they want to plan for something that is very future proof? Do they not care? Are they aware that, if you don't include any future conditions, that pretty soon the thing that they're paying to build could be negatively impacted, and they could experience downtime or safety measures that are hindered, or there could be negative effects. Just having those client conversations to understand where you need to aim for as an engineer, I think, are important to have up front. And so that'll also include some financial considerations as well. So cost benefit of including certain design adaptations versus not. And so I think I'm picturing some sort of a form that's done early, and, it doesn't literally have to be a form, but answering those questions in your mind, whether you're a design engineer or even on the client side, managing a project implementation plan or a specific project being built. I think these are good questions that everyone should be asking.
Matt, it's been really good talking with you today and learning more about resiliency and sustainability and all those pieces that come with it. What's one final piece of advice that you'd like to share with civil engineers aiming to build more resilient, future-ready infrastructure?
Yeah, I think repeating some of what I've said, but reiterating that, as engineers, we're trained on historical data. In my life, as a mechanical design engineer, we were looking at ASHRAE conditions that I think in most cases were predicted or you not predicted. They were based on data from 1987 to like 2012. That time period is what they got the design conditions from. And so we're trained on this historic data, but as we've seen and as we continue to see, the climate extremes require forward looking design. And to really meet that standard of care, I think I would encourage everybody to put that lens on when you're in the early stages of your project to figure out, look at the asset that you're designing or the campus you're designing, whatever it is, and put it in 30 to 50 years from now. What will the asset or the campus look like in 2070 when these things that are designed are still expected to be operating as they're designed today? And putting that lens on, I think, will highlight, do I need to consider more flooding risks or heat risks or wildfire or drought or, things that aren't just the normal, 100-year floodplain and assume we're good type of thing. So I think just putting that lens on is my final piece of advice, and answering the questions that come along with it.
Be forward thinking. Don't necessarily be thinking back, making sure that we're protecting ourselves for the future, not necessarily for what we have right now. Matt, great stuff today. Really appreciate it.
Exactly. Yeah, thanks so much. This was a great conversation.
All right, now it's time for our CE Hot Seat segment of the week with Matt Huddleston. Are you ready to go?
Yes, I'm excited.
All right, Matt, do you have any specific rituals that you practice every day? For example, specific morning ritual, lunchtime ritual, things that you do consistently on a daily basis that contribute to you being a successful professional?
Yes, so I have a few that came to mind. One, I'm a big list person. So I'm constantly organizing and prioritizing my to-do list. I think it helps me personally manage my stress and understand this is what I need to do today. This is the priority today. I need to get through these things. Helps with time management as well. And I think that, the trickle down effects of that are countless, but I think, one helps you meet your responsibilities, helps you meet client expectations. And so I think, I would probably feel pretty lost without my list. And so I think that's one that is a daily ritual, not just in the morning or at lunch, but maybe once in the morning, once in the afternoon, and nothing better than crossing something off the list as well. And I think one on the
Hold on, real quick
yeah.
on that. Do you add things to the list that weren't on the list to cross them off?
Yeah, I do that.
Yeah, I do that too. Sorry, good.
Yeah.
Continue.
So, one that is less, I don't know, technical or engineering related is I'm definitely an avid runner. And, I think psychologically, it probably relates to the list habit pretty closely. But I find getting out on a run in the morning, my brain is clearer, my days are more productive and enjoyable. And I think that just gets my brain ready to cross things off the list. And so I think that's another, if not daily, almost daily routine.
What is one book that you recommend to engineers regularly, or just one book that you have found to be extremely helpful in your professional or personal development?
Yeah. So in the resiliency space, I think it's still a kind of new term, especially in the engineering world. And so a lot of times we find ourselves being in more of an educational role, at least up front in a project or within our company. And so I think learning how to communicate the value has been a journey that I think applies far beyond resilience. Educating people and helping people understand your perspective is always helpful in personal life, professional life, and across disciplines. And so there was a book called Pitch Anything that I've found really useful in just helping to lay out best practices for how to do that. So how to pitch your idea, how to communicate its value, and help the audience, whether that's partners or clients, to understand your why, and also how they might accomplish your why and the value that you see in it.
Thinking back on your managers of the past, picture your favorite manager or managers. What was it that made them your favorite?
Yeah, so I've been lucky to have a lot that I would consider people that I really enjoyed working under. And when I think back on them, I think they're normally the ones that I got along with best, not surprisingly. So whether that was because we had compatible personalities or compatible working styles and compatible priorities, I think it was a combination of all of those. But I think all of them shared that consistent personable nature, being really good with people. And I think what comes with that is they had my interest in mind. They are, while they're driven to innovate and driven to exceed client expectations, they were also focused on along the way developing our working relationship to be, a collaborative team. I think collaboration was a big one.
Hmm.
Not only did I learn a lot from them because in a lot of cases they're way smarter than I was. They're way more experienced than I was. And I learned a lot, but also it was, a collaboration where they took my perspective into account. And, it was not a, trickle down. It was more of a give and take and a collaborative relationship that we had. And so I think all those, I really come back to the personable nature that they all had and their ability to connect and respect each other.
I've got one final question, and that is the critical civil engineering career elevator advice question. If you got into an elevator with a civil engineering student and had about 30 to 40 seconds with them, what career advice would you share with them?
Yeah, first I would say great choice because it is such a flexible degree. There's so many different avenues you can take. And so find something that excites you that is even semi related to civil engineering and continue learning about that and continue innovating because, the world isn't standing still. And I think the more you are a continuous learner and the more you pursue your excitement, I think your career can take you you're really wherever you want. And I've kind of followed a unique path, and I think that beginning in the civil engineering educational discipline it lays a strong foundation, pun intended. And I think all you have to do is continue learning and follow your excitement.
Matt, thank you so much for joining me today. Where can our listeners connect with you?
Yeah, I'm on LinkedIn, or I think you can find me on Stanley Consultants website and reach out with any questions. Always happy to talk about resilience, whether it's a short conversation, long conversation. I love chatting, and I'm also at conferences fairly often, so I hope to connect with some people out there.
So LinkedIn, Stanley, or also check them out at the upcoming conferences. So Matt, thank you again. Appreciate all your wisdom, and hopefully we'll talk again soon.
Thanks so much.
Please remember you can find the show notes for this episode at civilengineeringpodcast.com. There you'll find the summary of the key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during the episode. Until next time, I wish you the best in all your civil engineering endeavors.